Hello, Algebra 2. Tonight's topic is sequence and series. And my essential question, there's two of them. And the first one is, what is a sequence and series? The second one is, do I understand which formula to use when? So the first thing is, what is a sequence? And a sequence is an ordered list of numbers. And each number in a sequence is a term of a sequence. So if you wanted just to have a quick example of that, you could have a sequence where it went 1, 3, 5, 7, 9. And you can see there's a pattern here. And we'll be talking more about patterns in a minute. But a sequence, the key first is understand this vocabulary of a sequence. And it is an ordered list of numbers. This is one example. And each number in a sequence is a term of a sequence. So this is the first term, the second term, the third term, and the fourth term, and so on. Okay, the first thing I want you to, before we go any further in the notes, I want you to realize that on the Algebra 2 formula sheet, our SOL test will be given this formula sheet, and for the rest of the quizzes and tests this year, you will be giving it as well. So notice we have our geometric formulas, a quadratic formula. The unit we're currently in will be going over most of these formulas, so that's why you'll be seeing this a lot. After we talk about sequence and series, we'll be talking about statistics and permutation and combinations. So the formulas I'm going to be talking about in today's notes are all listed here. Sequence and series formula. They give you this notation and they explain it on the formula sheet, so we do not have to memorize it. And all the formulas I'll be talking about today are given to you on all the quizzes and on the SOL test. So notice where they are on the formula sheet and realize that today you just have to understand what formula is what, and you do not have to memorize them. Okay, so let's continue on with the notes. And the first thing I want you to realize that all of these sequence and series, they could have patterns to them, and they will have patterns, especially the sequences that we'll be determining. But not all sequences will be the arithmetic and the geometric sequences. So first, let's just think about a list of numbers, a sequence, and what the pattern might be. So for our first example here, and before we go and talk about first example, let's change number 3 here. It should have another, there's not a pattern without adding another number, so we need to add the number 9 in between 4 and 16. So it should go 1, 4, 9, 16, 25, 36. So first I want you just to look at this sequence and pause the video and come up to see if you can recognize the pattern between 1 and 4. Okay, for number 1, you should see that each term you're going to add 3. 2 plus 3 is 5, and then if you add 3 to 5, you get 8. So each term you're adding 3. For number 2, the pattern is different. We're multiplying by 2. So -1 times 2 is -2. -2 times 2 is -4. So that pattern is multiply by 2. For number 3, it's different. 1, 4, 9, 16, 25, 36. Also 4 is a little bit different. If you haven't determined the pattern, go ahead and pause and try that. For 3, there's a couple ways to talk about it. You could say 1 squared, 2 squared, 3 squared, or you can just say it's listing our perfect squares. In order. For 4, you can see the pattern is adding 1, and then adding 2, and then adding 3, and adding 4. So a lot of what we're going to be doing today is recognizing the pattern and understanding these formulas. And the first thing to realize is the notation, and n is not given to you on the formula sheet. So do understand that n is going to be the number it is in the sequence. So this is one you'll have to remember. So n is the number it is in the sequence. Now an is given to you on the formula sheet, and what it says there is it represents the value of the nth term. Alright, so let's break that down more so we understand what this means. And if you look at our first example, this is a sequence, and you can see that the pattern is adding 5. If I add 5 to negative 7, I get negative 2. And then if I add 5 here, we get 3. And 3 plus 5 is 8. So you can see that pattern is add 5. But the questions they ask are not about the pattern, they're asking about this notation. And what A1 means is they want you to tell you the value of the nth term, so in this case the first term. So we just look at our sequence and look for the first term. So that would be negative 7. Okay, so when it comes to the second question, they want to know what A4 is. So that would be talking about the fourth term is what they want to know, the value of the fourth term. So 1, 2, 3, 4. This is the A4, so the value of A4 is 8. And then the last question is telling us that AN is 18. So they're telling us the last term that's listed here is 18. So to find what n is, we just have to determine what number it is in the sequence. So it's 1, 2, 3, 4, 5, 6. N would be 6. And so A6 is 18. All right, another is a recursive formula, and a recursive formula is which relates each term after the first term to the one before it. A formula, again, recursive formula is a formula which relates each term after the first term to the one before it. Our recursive formulas, you'll see, are given on your formula sheet again, and you can see them listed here. So let's talk more about what they are. And see this one, a n minus 1 plus 4. And sometimes it'll be the one given on your formula like this one is. Other times they'll add something to it. And we'll have to be able to determine using the exact formula. But the key is to realize this a n minus 1 is the previous term that you're going to be using to build on the next items. So that is the key to understand that notation, that a n minus 1 is a subscript. They're talking about the previous term that you're going to determine before it. You're going to use that to build your formula. So for example, number 1, the first term is 2. Every term after that is going to be built from the term in front. So our A2 is going to use, so if we plug in 2 here for n, 2 minus 1 would be A1. Let's just show that. But it's probably easier to think of as A1 plus 4. So A2 is going to be the first term plus 4. So that in this case it's 2 plus 4, so that is 6. So our first term is 2, our second term is 6, and then to find the third term, we're going to plug in our 3 minus 1 here. So that's really talking about 3 minus 1 is 2, so it's talking about A2. So for A3, we're going to find A2 plus 4. So our second term is 6. So 6 plus 4 is 10. For our fourth term, we're going to be plugging in 4 here to n. So 4 minus 1 is 3. So I'm going to be using my third term and add 4. And then so 10 plus 4 is 14. And then our fifth term, we'll be using the fourth term and adding 4. So 14 plus 4 is 18. So you use the term in front to determine the order, the next term. Go ahead and pause the video and try this one. This one's a little different. Once you've used the previous term, you have to multiply by 2 and then minus 1. Okay, so you should have found the second term by using the previous term. So 3 times 2 minus 1 is 5, and so on. The third term would be 2 times 5 minus 1, and the fourth term, you do 2 times 9 minus 1, and the fifth term would be 2 times 17, and then minus 1, because this formula is listed, and again, this a and minus 1 is called the previous term. Use the term in front in the sequence. Okay, so an arithmetic sequence is when the pattern is adding. There's going to be a difference between two consecutive terms that's constant. So an example of an arithmetic sequence would be 2, 4, 6, 8. And here we're adding 2 each time. So the constant or difference, that will be 2. And the difference is found for arithmetic by taking the term, either the second term and subtracting the first term to get that 2, or the third term and subtracting the second term, but it should be a constant each time. So if it turned out that this was like 11, then this would not be an arithmetic sequence. It must have the same number that is being added each time. And they call it a difference, which is interesting. But understand you find that difference, you take the second term and subtract the first term, and then make sure it's consistent throughout. The equation for an arithmetic sequence, again, this is given to you on the formula sheet, is so you can find any term by using the first term plus n minus 1 times d. So the d can sometimes be given to you, or sometimes you have to determine it from the pattern. But they would have to either give you a way to find the first term or give you the first term, and then they'll be asking you which one to find. So let's first look at our example of number 1. And they want us to write this equation in terms of this sequence. So first, they didn't give us the d. We're going to have to uncover the pattern. So I'm going to look at the second term and subtract the first term. So my d is going to be negative 5 minus a negative 10. And that would be negative 5 plus 10, which is equal to 5. And let's make sure that's the pattern. We're adding 5 each time. And that does work. If I add 5, I get 0, and add another 5. So our d is 5. So to determine the, we also need to know the first term, and they gave us that. That's negative 10. And now we just have to plug into our formula, because I just want the equation of the nth term, so any term. So an, our first term is negative 10. And then depending on which one they ask, we'll have to plug the n in. So it would be n minus 1 times our d, which is 5. Okay, there is going to be a second short video. Before you start that second video, I want you to make sure you understand this first part. So in the summary, I want you to answer these two